Hello community, isn't this fascinating? We have now Agentic AI. And you said, hey, wait a second, what is an Agentic LLM in scientific detail? And you ask, is it related to the AI agent that I just programmed? And what does it mean, as my prof is telling me, I have to increase the RAG agency of my system? And are RAGs agentic? And what exactly is the mathematical and scientific definition if I want to improve here my agency? So great that you ask, because I have to tell you, I don't know. This is such a beautiful marketing buzzword that have here a new hype in AI. And now you give me the opportunity that I can learn, and let's have a look what I found out. Now, if you go, for example, Llama Index, as you can see, we have here official homepage, Agentic Strategies. Llama Index RAG pipeline here. This is beautiful. And you even have simpler agentic strategies. And I have no idea what this is. And then you look here and I put in Agentic RAG in Google. Yes, I just use Google. Imagine, I'm that old fashioned. And you have here Agentic RAG system, Agentic RAG in any enterprise, AI agent and the agentic processes. And you might say, unbelievable, we have something fascinating. So let's look, what is agency? Agency refers to the capacity of an entity, not specified if it's a human or a mechanic, to act independently, make its own choices, impose its will on the world. It involves intentionality, self-determination, and the ability to execute actions based on personal motivation and goals. The key characteristics of agency are autonomy, intentionality, self-determination, and responsibility. The entity can be held accountable for its action. And OpenAI says, hey, this is great. So GPT is responsible and accountable also in financial terms, whatever GPT is doing to its users. And so all the big, beautiful global corporations say, yeah, of course, we have agency in our AI, because then the systems are responsible and not we as a company. And you might say, this is fascinating. Of course, it's also that the agentic lifestyle may come from an AI agent, being an agent itself. So, an AI agent refers to a computational system designed to perceive its environment with sensors, reason about it, and take actions to achieve specific goals. It operates based on algorithms and data, executing tasks autonomously with its programming constraints. Key characteristic is autonomy. It operates without direct human intervention, making decisions based on predefined rules and learned data. It has its own perception using its own sensors and its own input structures. It can do reasoning using the algorithm, and it can act. It executes tasks or behaviors to achieve specific objectives. Now, what are the key differences between agency versus an AI agent? And there are 3 points. It's the source of intentionality, the nature of the autonomy, and the responsibility and the accountability. So in summary, we can say the agency refers to an inherent capacity for an independent action, intentionality, and self-determination, typically associated with living beings. An AI agent, on the other hand, is a computational system designed to operate autonomously within the constraint of its programming, perceiving in its environment, reasoning about it, and taking action to achieve predefined goals. And yeah, taking action limits this more or less to a robotic system. So the primary distinction lie in the source of intentionality, the nature of the autonomy, and the framework of responsibility and accountability. And you say, okay, so if I have now the word agentic, is it referring to agency or is it referring here to the agent? because those are two different systems. And I had a brilliant idea. I say, hey, we are talking about AI systems and large language model. So let's ask the LLM a question. Are they agentic? What do they think about themselves? Because those are the artificial intelligence system that it's all about. In the upper right corner, you will see here the model that answers. And I asked about 12 different LLMs. So Gemini 1.5 Pro, a beautiful new system, says, hey, in, let's call it, human psychology and cognitive science, agency refers to the capacity of an individual to act independently and make their own free choices. It encompasses several key components from intentionality, forethought, self-reactiveness, and self-reflectiveness. Crucially, agency implies a level of consciousness and internal experience that goes beyond simple stimulus-response mechanisms. So Gemini 1.5 Pro, yeah, that sounds good. Then I ask a Llama 3 70B instruct that everybody loves. And Llama 3 tells me, hey, while LLMs are incredibly powerful and versatile, they are not inherently agentic systems. And Llama 3 goes on and explains, here's why. They lack autonomy. LLMs do not operate independently and require human input, such as prompts or training data, to generate responses. LLMs have a limited intentionality. LLMs do not have inherent goals or motivations. Their intentions are largely determined by their training objectives in the input they receive. And there's no self-efficacy. LLMs do not perceive themselves as capable of influencing their environment or achieving goals beyond generating text based on their programming and on their training. So Llama 3 tells us, no, LLMs are no agentic systems. And I have here a short discussion with Llama 3 70B and I say, but wait, LLMs can be designed like the latest Mistral version 3, designed to call external functions or APIs, enabling them to interact with other systems, with their environment, to receive new information or perform specific tasks. Is this not an agentic way? And Llama 3 comes back with its own logic and says, in this sense, an LLM's function calling ability can be seen as a form of scripted agency, where the model is programmed to execute specific actions or call functions in response to certain input or conditions. While this is not a true agency, it is a powerful tool for automating tasks. So Llama 3, quite clear on this topic. And Llama 3 goes on, hey, to illustrate the difference, consider a chatbot that uses an LLM to generate responses. And the chatbot will be able to call external functions, like Mistral version 3, to retrieve information or perform tasks. But it is still a scripted system that lacks autonomy, intentionality, and self-efficacy. In contrast, a true agentic AI system would be able of making decisions, adapting to changing circumstances, and exhibiting autonomous behavior. And if you think here about a certain movie about the future of the machines, you do not want that an AI exhibits some real autonomous behavior and connect to the internet of the world. Okay, this was Llama 3. And I go to Gemini 1.5 Pro and say, hey buddy, you know me, no? So can you do a scientific comparison between this function calling and LLMs that is so beautiful to this strange word agentic that everybody says is here? And Gemini 1.5 Pro comes back and says, hey, the term agentic and the term function calling describe distinct capabilities, so they can appear intertwined in the context of LLMs. So let's do a definition. By agentic, being agentic, It implies having the capacity for independent action and goal-directed behavior. This involves a goal formation, identifying desired outcomes, and formulating plans to achieve them. Please remember, this is so important. Formulating plans to achieve them. I'll come back later in the video to this point. Second, action selection. Choosing actions that maximize the likelihood of a goal attainment, and a self-monitoring. It can self-evaluate its progress. Now, on a biological basis, tells me Gemini, agency is a complex, emergent property arising from the interaction of various cognitive functions. And I thought, yeah, this is exactly what I'm looking for in my AI, no? It's a complex, emergent property, and it comes from the interaction of billions of little GPUs. But unfortunately, Gemini tells me, hey, the perception, the memory, and again, we have here the planning. So creating mental representation of future actions and their potential outcomes. Yeah, okay, this is not what an AI system is currently able to do. And Gemini goes on, while AI system can exhibit behaviors that kind of resemble agency, they are not truly agentic in the same way as biological systems. Because this AI system lacks 3 points: consciousness, self-preservation, and intrinsic motivation. Fascinating. I said, this is real nice. So, coming back to the question of agentic. Agentic represents an advanced form of intelligence characterized by goal-directed behavior, self-monitoring, and, again so important, adaptive planning. And Gemini tells us LLM, while they are impressive and beautiful, LLMs do not possess true agency. And function calling, what I ask here, is a powerful tool that it enhances the LLM's capability by allowing them access to external sources and perform tasks beyond their textual limitations. However, function calling does not equate to agency. So I have to say, those LLMs are really clear what they are. Now to my green grasshoppers, yes, I know you are listening. This function calling, if you're not real familiar with it, it is simple. It just has 4 steps and you can do function calling on your LLM, like your Mistral version 3.03. So at first, you're not going to believe it, you have to define the functions. Then you specify the function schema. And we use here normally a JSON schema. Then we prompt our LLM with this, and then we execute the function based on a function call generated by the LLM. The LLM executes the function with the provided arguments and returns to the result. So you see, define function, specify schemas, prompt, execute. Let's have a look at this. What is the code? Step 1, define the function. Simple. Step 2, define the function schema. Let's go with a JSON. You have a function, you give it a name. If you are a nice coder, you give it a description so other people understand what it is, and you define the parameters. For example, you say, hey, I have here an object with a property of a location, and the description is the city and state, like San Francisco, California. And I have a unit, a string, that gives me Celsius or Fahrenheit. And required is only the location. We have a schema defined. And then we prompt the model with this. We say, hey, the role of the user is, question, what is the weather like in London? And now we use here the tools command. And we define what tools the LLM can use. Let's say here OpenAI chat completion, we have go with GPT-4. We have the functions, our tools that are defined. And now we just defined one function, but we can define multiple functions. So if we want the system to choose the function, we say function call auto, or we specify our specific function. What is the weather in London? And then we execute the function with a function call. The name get the current weather, the augment is London, and the unit is Celsius. And you execute the function with this command. This is it. This is function calling. If you want to learn more about it, I would like to recommend here Mistral, function calling. They have a beautiful summary. Let's have a look at this. Mistral AI has here real beautiful information for you, function calling. You have a Colab notebook you can follow along. You have a video you can follow along for Mistral specific function calling. And if they tell you the available models are Mistral Small, Large, and the Mistral, now also here, the latest Mistral version 3 is also doing function calling. And I tell you, hey, there's 4 steps. You have a user, a model, execute the function and generate the answer. Easily explained. And if you want to look at the code, they go step by step and they explain for each step which tools are available. They show you here the Mistral specific code for the Mistral specific models. If you have the tools, how you define function 1, how you define function 2. Beautiful, explain, go there. You have your user query. Step 2, the tool choice. As I told you, for example, here auto. The model decides which tool to use. Any forces, here the tool use, or none prevents a tool use. Of course, you need your Mistral key, and you have here step 3 and step 4 explained beautifully. Now, if we go now to OpenAI, we have the same. We have here function calling, a beautiful description. They introduce you what is function calling in an API call. You can describe function and have the model intelligently choose to output a JSON object containing arguments to call one or many functions. You have the chat completion API does not call the function. Instead, the model generates JSON that you can use to call the function in your code. Those are the models that have these use cases. For example, create assistant that answer question by calling external APIs, convert natural language into API calls. So you say, hey, who are my top customer? If you have a company AI, this is then converted into the function get customer minimum revenue at a threshold created before and the limit, and calls your external or internal API, or you have structured data from a text. So you see, beautiful demonstration. They tell you the behavior. They even show you parallel function calling. Remember, you have to pay for each function calling. No, this is not a way to get you out of this. And they show you how to invoke multiple function call in one response. You can copy the code. It is immediately available for you. And it all follows the same schema. There might be some small code adaptation if you work with OpenAI or if you work with Mistral. Never mind. Also would recommend here the literature from Ollama, because in the new Ollama updates, you can work now with the Ollama raw mode, and Mistral version 3 is also able to use raw mode, which is a beautiful thing I will do in a later video. So coming back, I know you have been waiting for Claude 3 Opus. All my subscribers say, hey, I like Claude. Here we are. And Claude tells us the concept of agency in AI is still an active area of research. While LLMs with function calling ability demonstrate impressive language understanding, they may not yet possess the full range of characteristics associated with agentic systems. So not yet agentic systems. So also Claude 3 Opus tells us LLMs with function calling are not agentic. And I ask Claude 3 now, hey, can you tell me here the differences between being agentic and the function calling ability? Isn't it the same? And Claude comes back and says, hey, no way. I have 5 points where I can show you it is not. Let's look at autonomy. An agentic system has a high degree of autonomy in decision making, whereas the LLM function calling ability is more dependent on a specific input and a predefined function. It has been trained, the user defined, to recognize and execute the command. A second point, the goal-directed behavior. A Agentic systems have their own goals and can adapt their own behavior to achieve those goals, while LLMs with function calling ability are primarily focused on executing the requested function based on the input provided. Point 3. Adaptability. Agentic system can adapt to new situations and learn from their experiences. LLMs with function calling ability are limited to the specific function they have been trained to perform and may not be able to adapt to novel situations without further training. Point 4. Self-regulation. Agentic system can monitor their own performance and make adjustments to improve their effectiveness. LLMs with function calling ability do not inherently possess this level of self-regulation and rely on external human evaluation and fine-tuning to improve their performance. And point 5, the contextual understanding. Agentic systems have a deeper understanding of the context and can use this understanding to inform their decision and actions. LLMs with function calling ability have some level of contextual understanding based on the training data, but are often more limited. So this was Claude 3. And then I looked in total at 12 LLMs, and believe me, like Gemini Flash, attributing full agency to LLM is premature. QN, no full agentic systems. QN 110B, not qualify as agentic system. And then we have a funny one that does not exist at all, a Gemini 1.5 Pro tune that is not official here yet. And they say, hey, it falls short of the criteria for an agentic system. So LLM, by all means, every LLM tells me, LLMs are no agentic systems. Yeah, here this Pro tune, this secret stealth LLM. If you ask here the characteristics of an agentic system, it has a different twist to it. Look at this. It says, agentic systems are defined by goal-directed behavior, autonomy, perception, and action. But it's a little bit different. If you read it in detail, you will understand what I mean. Okay, I went back to Gemini 1.5 Pro, the new API preview, and it tells me, hey, function calling with LLMs still lack inherent goals or motivation. There's no long-term planning. There's a limited autonomy. And function calling makes LLM a beautiful tool, but it does not transform them into independent agents. So LLMs with function calling are no agents. Now this planning, as you noticed, maybe, since I mentioned it several times now, is of crucial importance for the next step, for the next evolution of AI systems. Agents can conceptualize future states and strategize pathways to achieve the desired outcomes. This involves considering different options, anticipating obstacles, and making decisions based on predicted consequences. This is not an easy task for an LLM. Now, let me give you a very simple idea of mine. Whenever an AI system encounters here a specific task where it would need to utilize a new function it has not been programmed, that is not in its memory and does not know how to connect to external sources, this AI system should be able to create it with its given set of functions, this new adequate function. If it has access to a Python environment, it should be able to self-code this new function and integrates this syntactically generated new function in its own set of function, which means for me kind of a self-learning. This would change the game significantly, but we are not there, not at any means. Where are we today? Our best systems, and I will show you later on, they are a DAG, a directed acyclic graph system. So we started a node with a function or an operation or whatever you like, then either we go in A or either we go in B. And if we went to A, then we have maybe the option here to go over there and perform this task. Or maybe this node tells us, hey, you have three possibilities. Given your specific input data or your specific threshold or whatever parameter you have, You can go either to A1, A2, or A3. But this is a predefined structure. And this predefined flow that some system try to integrate into a multiple function calling set of operation, it is not what we are looking for. Because this is just like SAP for business finances. If you want to calculate your, your profits in your company, well, you start with the cost, then you divide the cost, per staff, and you divide this then by another criterion, you compare it here to your revenues, and somewhere down the line you have a clear defined flow of mathematical operation, and then the SAP system generates here the statement of your financial profit in the company. This is a known way how to do financial calculations. There is no intelligence because I, as a programmer, I predefined here the way of the logic that the system should follow. And please, in business finances, there are national laws. So I have to make sure that all of these steps are followed and calculated. But this is not an AI system. This is a Python or SAP system for business finances. So you see the difference? But currently we're here and we want to go over there. So whenever an AI system encounters a new task, now the AI, and now the first question, is this really the task of a large language model, learns and decides what programs or function calling to activate in the flow. And you see, in my other videos I talked about causal logical reasoning so much, and now you understand why. Because this reasoning ability, let's say of an LLM, is an essential feature for the planning the logical path of our AI system to the desired solution, but not a predefined flow of operation that is necessary if you want to go with your national accounting laws, if you want to calculate your business finances. So you see where and how strong you apply AI logic is a complete different game. And then I know you have been waiting for this about RAG. And I know that my subscriber says, hey, if there's an obstacle, I just build a RAG system and RAG solves everything. RAG is a unique solution to the problems in the world of AI. Or maybe not so. Okay, so RAG, yeah, beautiful. So what is RAG? It is an information retrieval module and a large language model. Now we know that a large language model is not agentic. It is not an agent. It does not have agency. So you might say, hey, no problem, then it is here the combination, no? Okay. Let's look at the key differences between the RAG and a standard function calling AI system. And we look here at the dynamic knowledge integration and the improved factual accuracy and the relevance, the grounding, and some domain-specific expertise. You can read this or I can tell you, RAG is just a not as powerful function calling. Because with function calling, I can access Python system, interactive system. It can have robotic system that really act in the external world. With RAG, I just retrieve information. So RAG, let's be progressive, is a little subsystem of function calling. Because we only have to retrieve it, the augmentation that is done in the LLM, and the generation that is done in the LLM. But function calling is a much more powerful system. Now, there are multiple ways RAG can access this beautiful external information. You can have here, just here on your local file system, or you go to a network file, or you go here with SQL or SQLite. You can have a Mongo client that you say, beautiful, this is the way. Or you go here with access S3 data. Or you go here and you have an SSTP protocol. Or, and this is normally also happening, you have an API call. So you see multiple ways that two external information can be accessed via RAG. And then, let's make it short, I ask here, so LLMs with their function calling abilities and RAGs with their information retrieval engine, they're just simple AI systems that both lack agency. And I say, would you agree? And if not, explain in scientific terms, why not? And I asked 12 LLMs, and all the systems told me this. And I have here a Llama 3 and a Gemini, and I said, yep, RAGs also lack agency due to their limited autonomy, lack of self-awareness, and predetermined operational parameters. And Gemini tells us, yes, also lack inherent agency in the same way humans possess it. Characterizing them as simple, however, is an oversimplification. So Gemini said, yeah, I know it, they don't have agency, but you know what, they are not really simple. Okay, I see what you want to do, Gemini. And of course, if you want to experience the other 10 yourself, just say go to lmsys.org, put this in. This is the screenshot here from my last, what I showed you. And you have then a Llama 3 or a Gemini. Do it in a blind test. You will be surprised how different models, different LLMs answer. A different kind of pathway of the argumentation, but the result is always the same. RAG are not agentic. That's it. So here we go. What we have proven until now. There are no agentic LLMs. There's no agency to a RAG system. So you can go back to your professor and say, you know that you're wrong, huh? So what is it that we are looking for? And what is the cool new buzzword that we should use that somebody watches here? Some new, I don't know, information on some platform. And are we interested in this, or do we all understand that these are just buzzwords for marketing, like agency and agentic? Or do we take the step and say, hey, those terms have a scientific meaning and it's important to understand because they open up a new avenue for our development. And I go, of course, with the second one and I say, have you noticed that in the whole session up until now, planning seems to be the most emergent functionality of the system we have to talk about? And from Lillian Wang here, this is a beautiful, very old statement. What is an agent? And she did an equation. An agent is an LLM that has quite a long memory, internal memory structure with 2 million token context length, can use tools like our function calling abilities, and has a plan what to do if given a new task. And this is this beautiful planning. So you see, it was all the time there. Just all this marketing really shifted our focus where it should be. Now have a look at this. Today we think that the LLM is the main course, the main source of logic. That the causal reasoning of an LLM is essential for the planning strategy of the whole agent system, if it would be an agent. But there's also another option we are now starting to explore in AI research. That a plan what to do is not the LLM, but is a world model that is based on scientific laws, on the laws of nature. So you say, hey, this is interesting. So we have now two kind of intelligence system. The rest is just tool use, just planning here, new steps. So let's look at the key aspect of planning in a theoretical true AI agent. We have goal setting, strategy development, action sequencing, like in robotics, and then the execution. And yeah, you see it all goes to robotics, to visual language model that interact in an external environment. So goal setting is easy. Establish specific objectives that the agent aims to achieve. Strategy develop. You create a plan, planning, strategy, outline the step necessary. Okay. The action sequencing is nice Because remember, the action sequencing, the LLM would know theoretically what to do, but it doesn't understand why. So there's some treasure hidden here, and the execution. The importance of the new planning functionality in our new real AI agents, it would have to increase here the efficiency, the effectiveness, the adaptability, and it will reduce errors. And I've given you here examples in logic, healthcare, stock trading, and manufacturing. And you might say, but wait a second, what exactly is now the difference between planning and function calling in LLMs? Are they not somehow related? Because if you have a set of 10 functions, and this LLM learned to differentiate when to call each specific function and in what order to call each specific function in a kind of time series, no, there is some underlying difference. Look at this. We look here at predefined functions by the user, function calling framework structure, and the limitations in its adaptability. So the function need to be defined by coders, by developers beforehand. I define the function that my system needs for a task. So the function are only actions the LLM can call during its operation, and we have a training and fine-tuning that if I have a natural language command, the LLM understands, hey, this means I have to issue an API call to the weather station. The LLM uses the function call to interact with external system and databases. But those interactions are encapsulated and predefined within the defined functions. So there's nothing new to this system. It's just a mechanically predisposed system. And LLMs cannot improvise new action beyond the defined function. And this is a strong limit in its ability to adapt to new tasks. Now it's interesting if you look in the future, how can we enhance these planning capabilities? What if we move beyond an LLM as the logical central switching board? You can expand the function libraries. Like, I don't know, somewhere on an index you say, hey, this is now a database and I have here 10,000 functions defined. And I give you the description, what a function can do and what it should have as an input and what it should generate as an output. But you understand this is again kind of a database system. Creating functions from a variety of related tasks. The dynamic function integration. The system can be designed by training and learning a lot of training data to dynamically integrate now these new 1000 functions. This is also not really a sign of intelligence. And even if you combine it in a hybrid model, where you have a static and a dynamic planning, where a little bit of intelligence shines through in this dynamic, it is still not really what we want. So here we have now from the end of May 2024, a beautiful new archive preprint, agent planning. Now not with an LLM, but with a world knowledge model. And they say, currently, if we look here at a graph structure, it must not be a DAG. With the agent model, one action, another action, make a decision, go there, find out, no, not working. We have hallucination somewhere and we have a wrong link and whatever. This is a trial and error and this is really a problem. And they here propose here, hey, in our LLMs, we have the verbal world knowledge, but we do not know how to execute it. So we transfer this to a state knowledge, and this state knowledge, we can build here a graph structure from our semantic knowledge, and then with the nodes and edges and probability to travel along specific edges and the properties of certain nodes, we build here a new world view model in the graph structure where we have kind of predefined correct path to the solution. Of course, they need here to integrate real sensory data, continuous data that build up here as a copy here from the real world scenario. If you have a robot moving in a room, to build out a virtual twin, this virtual scenario of the world model. But currently we only have the description of our world in our LLMs, not the understanding. And they thought, hey, is it possible to use the verbal information, what to do, how the world works, that we have in our LLM, and kind of build an action model? Interesting. Another literature I would like to recommend to you, although it's not really the absolute latest, it is from February 2024. This is a survey done here from some beautiful institutions, understanding the planning of LLM agents, a survey. And if you want to see here the taxonomy of an LLM agent planning environment, it gives you a very good overview, and you are amazed how many system elements we already have. We already have kind of operational code, but we have not yet put it together. So, interesting literature if you're interested in this topic, I think, or if you just do your PhD thesis currently somewhere at the university on this beautiful planet, think about those topics, because those are topics that will be important in the next month. And another from end of May 2024, you see here LLM plus reasoning capability, causal reasoning, logical reasoning, plus the planning here in the presence of our APIs. Also an interesting publication if you want to have a little bit more of a deep dive, if you want to see where the current research is happening right now. So there you have it. We do not have an agentic AI today, but we understood what all the systems lack, what they are not able to do. And therefore we know on what elements to focus on for the future of AI. And you know, I think agentic AI systems are not that far off in the future. Maybe just years. And at the end of this, short personal idea, I want to show you where is code today. And I really mean today. And if we go here, for example, here, OpenAI Agent Query Planning, they are tools. And the OpenAI function agent with a query planning tool is already there. And if you go there, Llama Index, here is your link. But if you look at this, you understand the shortcomings immediately. Look at this. We have here an engine. The name is called September 2022. Provide information about quarterly financial data. Then we have another engine, and the name is now June 2022. Provides information about the quarterly financial, yes. And then we have a third engine, and you get the idea. And then we have here this beautiful new code, and it says, the query plan tool. So the complex now of planning. Yeah? It has 3 tools, and we have here the query tool for September, the query tool for June, and the query tool for March of 2022. And you might say, but this is just, okay. And then you have here the query plan tool, metadata to OpenAI tool. And you say, my goodness, this sounds so intelligent. But you know what it actually does? If you have defined your agent with OpenAI agent from tools, and then you have your function calls, and then you have here your LLM that you use, and you have defined here your query plan tool with your 3. And then you say, hey, now agent query, what are the risk factors in, and now September 2022. And you say, my goodness, is this intelligent? And then you hard code here from Llama Index, core, tool, query plan, import the query plan and the query node. And you have your query plan with the node, and you have the query node 1, risk factors, and the tool name is now, if you want to answer the question, what is the risk factor in September 22, you go with the tool September 2022. Okay, now this is of course just a demonstration of the code, and they say, of course, this should be a DAG system, and you have to start with one code, of course, and you go here with the first code, okay, but the real power of a graph interaction is not yet there in this open source community, but they are trying to go there. But however, if you read a statement here, like in the Llama Index, talking about agentic strategies, you have now for yourself to decide, is this just the marketing term, or is it really the scientific term that really provides an avenue to the future of AI? Because if you say here, like in agentic strategies here, in the official page here, that a lot of modules like routing or query transformation and more are already agentic in nature, in that they use LLMs for decision making, this is not agentic. This is simply plainful, scientifically wrong. This statement is not correct. This statement is a marketing statement, but you should be able to decide, or if you see this, that you understand exactly that this is not an agentic strategy at all. But I hope I've shown you in this video possible avenues to the future development of agentic strategies. But we should not give ourselves away this opportunity because there are some crazy marketing whatever just to get your attention, that we should lose the focus what is really necessary to achieve an agentic AI system in the real scientific terms and in the real scientific world. I hope you had a little bit fun today, you enjoyed it, you had maybe some new thoughts about something, and it would be great to see you in my next video.